Alright, so today we're just going to be making a quick video of my diagnostic briefcase. Carry it around like a businessman. So, the box on it says Snap-on Vantage, the MT2400, and that's the box I'm using, simply because that's what's in here, along with other stuff, and we'll probably get to that last. So first thing we want to start with is the test light. Everybody should have a test light. All a test light does is you hook one end to ground or you hook one end to power, and then if you hook it to ground, you can test for power with the other end. There's a little light bulb in there. If I find something that has a live feed from it, the bulb will light up. Boom. Just like that. Very simple. Works the opposite way too. If I put the clip on something with a live feed, I can go around and test for ground. Go to the battery. Boom. Very simple. Is the engine grounded? Well, it should be, because that's the way it operates. Yep, we got a ground there, because we got a ground strap going from the battery to the engine. A test light is a very, very simple tool, but it will do a lot if you use it properly. There's a whole lot you can do with it. The next thing everybody should have is a multimeter. Now this is just a cheapo $10 Craftsman off-the-shelf special, but it still works and it still does everything I need it to do. Now, since this is a 12-volt system and it's DC current, your house's AC, it runs at about 120-ish, depending on where you live. We're in the United States here, so that's pretty standard. This is a 12-volt, 12 to 14-volt DC system, so we're going to go to volts DC in that range, and then since we're at 12 to 14, we're going to go to the next highest setting, which would be 20. So we flip it to there, and now we're set up for that. For instance, I got the negative lead on the ground already. If I go to the positive side, look, touch the battery terminal, boom, we got 13 volts out of the battery. That's good. It's a fully charged battery right there. However, I can do a lot of other things with it too. If I want to find a break in a wire, put one end on the other side, go to the, for continuity, we basically have this little speaker type looking deal here, and that'll tell you if two things are actually connected with little resistance. For instance, if I want to find out if that engine's grounded or not, if I got some issue, I put one end of the line on one end of the wire, I can take the other lead, and it should make a noise and tell me approximately how much resistance is in there. So if I touch this, boom. See what we're doing here? Go to something even closer, like this this thing here, which really doesn't have anything left on it. Boom. Alright, so body's grounded, engine's grounded, cool, we're awesome. So if I was, putting an engine or something back in, or, redoing wiring or something, looking for a short, looking for a broken wire between maybe a speaker and a door, or a multifunction switch, or a window or something, I could find it. I could test the different ports and see if there's something not connected somewhere. Very simple. Awesome feature. So those two settings are what I mainly use the most, because basically that's all I need. Is I need to tell, if there's voltage and how much, and I need to tell if the wires are connected. Now this same test also, the other little thing there is a diode testing, and that tests, diodes obviously. So if you set it to there, all it does is it sends a little bit of current through one way and sees if it can pick it up the other way. So with this, you have to be very, very careful, and you can't always test things that go to the computer, or you can damage things because you're actually sending a little bit of current into it. So you got to be really careful, kind of understand what you're doing before you actually go ahead and perform tests. But this is a very awesome tool, and it can be used just in ridiculous number of ways with the right operator. Alright, next thing in this box is a basic scanner. Now this one can actually do live data as well, which is essential for diagnosing issues with your vehicle. Now my check engine light is on, and I know why, and I already know all that. So basically we're just going to plug in the scanner. It's very simple. They're pretty easy to use, especially these basic ones. They kind of do it all for you. So once that loads, cool, so it loaded. So basically what we can do is we can do things like read codes, live data, view the freeze frame, read the codes. Right now stored codes are Manufacturer specific codes not found. Press any key to select the vehicle. Oh, no, it's not a Buick. It thinks it's a Buick right now. So, alright, so I got a heater control circuit, O2 sensor, evap, and a torque reduction signal circuit. But this is for Buick, so the Dodge and Chrysler codes are going to be slightly different than that. But that's basically what's on there for codes. I know why. It's nothing serious, so I'm not really worried about it right now. So, live data. So we look at live data here. The vehicle's not running, so not all of it's going to be registering. But, for instance, we got ECT is engine coolant temperature in Fahrenheit. It's at 143 right now. No data and a lot of this other stuff because obviously the engine's not running. IAT is intake air temperature. You got a sensor over there that'll kind of tell you what the air is coming in at. And then some other data and stuff you can look at. Now this isn't for everybody. You kind of got to understand not only what these mean and what they're supposed to be at within the specific ranges, but you also got to understand how the systems work and how they operate together. So live data might be a little bit too complicated or too much for some everyday DIY people, and that's totally okay. There's always lots of great ways to learn about it if you're interested, but not a lot of people just in their average garage will be using something like that. So a scanner is awesome for stuff like that. Freeze frame data is basically when a code is triggered. It'll basically save all the sensor data at that specific time. And for instance, P0037, that's the code, and this will tell me, for instance, I was at 136 degrees in my coolant temp, so the vehicle hadn't been running for very long yet. RPMs 1024, so it was I was either going really slow. Well, actually, VSS is vehicle speed sensor miles per hour. So yeah, it was basically right around a little bit after idle. The code was triggered. I wasn't moving. The fuel trims look pretty good, but yeah, that'll give me a lot more clues as to why the code was triggered and what kind of conditions I need to either look at or replicate to kind of find my problem. So that helps a lot with that. And then it's got a bunch of other features and stuff. Component tests. It thinks it's a Buick right now, so it might not let me test anything. It might say not supported. Yeah, mode not supported in this because I accidentally clicked Buick. But anyway, yeah, that's a very basic scanner for you. And that's for this scanner here. It might be hard to see, but if I can get it out of the shade here. See what I'm looking at there is a pretty steady stream. I got multiple channels and stuff on here. I can actually see waveforms and get a lot more in depth with the electrical diagnosis. And right now what we're looking at is an injector pulse on a specific cylinder. So I can see that it's going steady. There's not, and right now there's not any problems with it. It's going good. But if it were misfiring and if for some reason there was I suspected there was an issue with the signal getting to the injector, I would see that in this waveform. I could see stuff like that. So that helps a lot with diagnosing stuff like that. If I want to test a specific sensor, I've set it up for, sorry guys, it's incredibly hard to see if I take that off. Alright, that's a lot easier to see. So I've set it up for 5 volts on volts DC, 1 second interval here. So if I want to test a 5 volt reference feed, I can do that. Yep, I got the 5 volt reference feed, and then depending on the sensor, I can test the resistance and the feed that's coming back out of it to the computer. So we'll get that in there. So we got 0.78 volts coming out of it at idle, and I could adjust the RPMs and do a bunch of different stuff and kind of really make sure that's within spec. So let me throttle it up here, although it might go right back down to that. Hold on. So we'll see how the signal changes as I rev it up. So the vehicle's off now. Obviously there's nothing going to be coming out of it right now, but you can see how that changed as I revved it up. Tested the 5-volt reference to make sure that reference feed was there, and then tested the actual signal coming out of that sensor. And with that data, we can compare it to what's in spec at idle and what's in spec at, you know, certain RPMs and whatever, to really test sensors and kind of 100% determine if something's faulty or give us a you know, better direction to go in. But this is basically a really fancy oscilloscope, and this is a really old one, but it still works. Electricity is still electricity. But that's basically what there is for tools that I use for most things. Now here's a also a couple little cool things that I got in this box. It's a mini circuit breaker that's on gator clip, so if I were to test something looking for a ground or something that was shorted out, or you know, something shorted to ground, instead of putting a fuse in line and constantly blowing fuses, having to stop and crawl out from under the car to change the fuse or whatever, the circuit breaker would just pop. I'd pop it back in and continue going. I'd know that, okay, there was a break there, and then continue going farther up the line or farther down the line depending on my results and what I was looking for. So a little mini circuit breaker to replace that inline fuse deal. I think that helps a lot because I don't have to constantly buy fuses or stop what I'm doing. I've also got another lead for the second channel on the meter, and then when I'm inside a vehicle testing things inside the console or whatever, there's not always a good place to get power or ground from that isn't already part of another circuit. So that cigarette lighter, I plug this into the port, and now I've got a power and a ground. And the cool thing about this is it's a good, safe, reliable circuit that really doesn't interfere with anything else, depending on the vehicle. And it's also fused, so should something ground out or have an issue, it'll just pop the fuse and not damage anything. Now, some of these go to the body control module and have stuff like that on the circuit, so you got to be really careful. I'm not sure if I mentioned this earlier, but the test light, since it is basically a light bulb on 2 sticks, it does transfer power. So if you hook this to ground and you're testing for power or something, a ground will get transferred through here, or a power will get transferred through here, and you can possibly damage transistors and stuff inside the engine computer. So you got to really be careful. If you're working with something delicate, use a meter, not a test light. But a test light's a good generic thing for, you know, testing bulb sockets and whatever. So there's that. There's my diagnostic briefcase, and just a quick demo of the stuff I got in there. So hope that gives you guys some good ideas to add to yours, and keep on keeping on.